Okay, so we're on page 3 of the packet, and this page discusses radian versus degree measure. Now, radians and degrees are just two types of units for measuring angles. So kind of like if you wanted to measure the length of something, you could measure it in centimeters, you could measure it in feet, you could measure it in miles, right? There's lots of different ways we could measure it. So same thing with angles. With angles, these are just two different units to measure angles. Now, up until now, we've really always talked about degrees, but now we're going to bring radians into it. Now, in order to convert from degrees to radians, what we do is we multiply by pi over 180. Okay, so in number 1, it says they want us to find the radian measure of each angle whose degree measure is given. So if we have 135 degrees, if we want to convert that to radians, all we do is we take that and we multiply it by pi over 180. Okay, now since pi over 180 is a fraction, I'm going to make this 135 into a fraction by putting it over 1. And when we multiply fractions, we just multiply numerators and multiply denominators. Okay, so 135 times pi is 135 pi. And then in the denominators, 1 times 180 is just 180. Now you want to simplify this. We're going to leave these in terms of pi. So this pi is going to remain in our answer. So basically to simplify, all you're going to do is figure out what 135 divided by 180 simplifies to. If you want to think about it logically, you want to find the biggest number that divides evenly into 135 and 180, which is 45. 135 divided by 45 is 3, and 180 divided by 45 is 4. So you could write this as 3 pi over 4. If you prefer to use your calculator, you can plug in 135 divided by 180 and hit math, enter, and it'll give you 3/4. So we're going to be left with a 3 on top and a 4 on the bottom. But don't forget, even though we don't plug this pi in our calculator when simplifying, don't forget to bring that down. So 135 degrees is equal to 3 pi over 4 radians. Okay, what I'd like you to do is hit pause and try to do the same thing for number 2 and for number 3, and then you can hit play and see how you did. Okay, so for number 2, if we're going to convert that to radians, we multiply by pi over 180. So I'm just going to put the 90 over 1. So when multiplying fractions, we multiply the numerators. So 90 times pi is just 90 pi. And then we multiply the denominators. 1 times 180 is 180. Now this one's a little easier to simplify in your head than the last one was. 90 divided by 180 would be 1 over 2, right? 1/2. So we could rewrite this as 1 pi over 2. Now, honestly, I normally don't put the 1 in front of the pi. It's kind of like instead of writing 1x, we normally just write x. So I'm going to rewrite this as pi over 2. Okay, so 90 degrees is equal to pi over 2 radians. Okay, and then in number 3, you do the same thing. You're going to multiply it by pi over 180. Okay, so when we multiply the numerators, 300 times pi is 300 pi. And then 1 times 180 is 180. And since 300 over 180 simplifies to 5 over 3, we can rewrite this as 5 pi over 3. Okay, now at the bottom of the page, we're going to do the opposite. Okay, we're going to convert from radians to degrees. Now, when we converted from degrees to radians, we multiplied by pi over 180. When we convert from radians to degrees, we multiply by the reciprocal of that. We multiply by 180 over pi. All right, so let's try these out. So let me just move this page up a little. Okay, so now they're giving us, in number 4, they're giving us pi over 4 radians. So if we want to convert that to degrees, we're going to multiply by 180 over pi. Okay, I mean, honestly, what I like to do usually is I just cross off the pi on top with the pi on bottom, and then you're left with 180 over 4, and you would just simplify that. If you prefer to multiply it out like we did with the last one, we could multiply numerators, right? We could say pi times 180 is 180 pi. And then we can say 4 times pi would be 4 pi. And if you prefer to cancel the pi's here instead of in the beginning, you can do that. So the pi on top cancels with the pi on bottom. And then 180 divided by 4 is equal to 45. Okay, so pi over 4 radians is equal to 45 degrees. Okay, so why don't you hit pause, try out 5 and 6 on your own, and then you can hit play and see how you did. Okay, so in number 5, we're converting 5 pi over 6 radians to degrees. So we're going to multiply by 180 over pi. All right, I'm going to do it the same way I did in number 4. I'm just going to multiply the top, multiply the bottom, and then simplify. So if I multiply across the top, 5 pi times 180 would be 900 pi. And then 6 times pi is just 6 pi. And again, if you prefer to cancel off the pi's in the beginning, you could have just canceled the pi here and here, and then you don't have to worry about them, okay? Or you can choose to cancel them here. And then 900 divided by 6 would be 150 degrees. Okay, and then finally number 6, we're going to do the same thing. We're going to multiply by 180 over pi. So when I multiply 11 pi times 180, that's going to give me 1,980 pi. And then 5 times pi is just 5 pi. The pi's cancel. And 1,980 divided by 5 is 396 degrees. Okay, so now if you flip to the next page, if we take a look at number 7, it says, which diagram shows an angle rotation of 1 radian on the unit circle? Now, when we look at the unit circle, we're used to looking at it in degrees, right? So we know that this angle right here, since it's in the first quadrant, it's somewhere between 0 and 90 degrees. I would say this looks like about a 60-degree angle. Okay, this one goes 90 plus another 90. It's a half a circle. This is 180 degrees. This one, from here to here, goes 90 degrees. And this one goes a full circle, which is 360 degrees. Now, they don't want us to look at it in terms of degrees. They want us to look at it in terms of radians. So let's figure out how many degrees 1 radian is equal to, and then we can figure out where it's going to lie on the unit circle. Now, on the previous page, we always saw radians written in terms of pi. So for example, we might have had, let's say, if you were to look back at, sorry, I'm looking back right now at number 4, right? It said pi over 4 radians. Now, if you, instead of that being in terms of pi, if you actually plugged in your calculator using the pi button, right, which is approximately 3.14, if you plugged in pi divided by 4, it would give you approximately 0.7854. Okay, a radian can also be written as a decimal or as a number, right? In this case, they're writing it as the number 1. But still, if I wanted to convert this to degrees, I would still have to multiply by 180 over pi. So let me erase this, because this doesn't actually have to do with our question, okay? This was just kind of like an example. If I want to take 1 radian, even though it's not in terms of pi, and convert it to degrees, I'd have to multiply it by 180 divided by pi. Okay, so, 1 times 180 divided by pi is just 180 over pi. It's itself. Now, if we want to look at this more as a degree measure, let's plug in our calculator 180 divided by, and I'm hitting the pi button, and I see in my calculator, I'm going to say approximately 57 degrees. So we want to look and say, well, which one of these shows approximately 57 degrees? It's going to be choice 1, because 57 degrees lies in the first quadrant. Okay, number 8 is very similar, just they don't give us a picture. They just want to know in which quadrant would an angle rotation of 3 radians lie. So why don't you hit pause, see if you can figure that out, and then hit play and see how you did. Okay, so if we have 3 radians, I'm going to convert that to degrees, because that's what's going to help me figure out what quadrant I'm going to be in. So 3 times 180 over pi, well, 3 times 180 is 540, and then 1 times pi is pi. And if I plugged in my calculator 540 divided by pi, it gives me approximately 172 degrees. Now, if we think about the quadrants, right, the first quadrant is between 0 and 90. The second quadrant is between 90 and 180. So quadrant 2, right, this right here, quadrant 2 would be our answer. That's where an angle rotation of 3 radians would lie. Okay, so if you can turn to page 5 of your packet, we're going to talk about arc length and radian measure. So what we just learned about on the previous page was a new type of degree measurement, which we call radians. Now, a lot of times we use radian measure when we're talking about a circle, okay? So I know in geometry you had talked about, like the degree of an angle, but here we're going to also talk about the radian measure of an angle. All right, now this is the formula we use. S equals R times theta. And you can see within the diagram what everything stands for. S stands for the arc length along the circle here. So let's label this. S is the arc length. All right, R just stands for the radius of the circle. So the R, sorry, that's supposed to be pointing at the R, is the radius of the circle. And then this theta right here is the angle measure, but not in degrees. It's always in radians. That's really important. Okay, so theta is the angle measure. And this is really important. It's in radians. So that's really important. Okay, I'm going to put in parentheses, not degrees. So if they give it to you in degrees, just convert it to radians. All right, so let's look at number 9. Number 9 says, in a circle, a central angle containing 1.5 radians intercepts an arc whose measure is 18 centimeters. Find the length of the radius. Okay, if you want to draw this out, you can. You totally don't have to. So we have a circle and a central angle. So if you remember from geometry, this is called our central angle. Okay, so I'm just going to draw a central angle like that. And it says it contains 1.5 radians. So I'm going to label that in there, 1.5. And it says it intercepts an arc. So this intercepts an arc right here, whose measure is 18 centimeters. Find the length of the radius. So we're looking for the R. Okay, so let's just use our formula. S equals R times theta. Okay, so for S, I'm going to plug in 18. R is what we're looking for. And in place of the theta, the angle measure is 1.5 radians. And remember, we want it to be in radians. If it's not in radians, you have to convert it. If it's in degrees, you have to convert it to radians. Okay, so then to solve for R, since we have R times 1.5, to get the R by itself, you would just divide both sides by 1.5. So 18 divided by 1.5 is 12. So we get R equals 12. And then the units would be, where is it? Let's see, centimeters. So the radius would be 12 centimeters. Okay, so let's take a look at number 10. A wedge-shaped piece is cut from a circular pizza. All right, so let's draw that out. We have a pizza, and we're cutting a wedge-shaped piece from it. All right, the diameter of the pizza is 12 inches. So the diameter would be the distance across the entire circle. So if we know the diameter is 12, we know the radius here would be 6 inches. Okay. The rounded edge of the crust of the piece measures 4.2 inches. So the rounded edge, mine's not so round, but it's supposed to be, measures 4.2 inches. Okay, to the nearest tenth, the angle of the pointed end, so we're looking for this angle here, of the piece of pizza in radians is, all right, so let's use our formula. S equals R theta. So S would be the arc length right here, which is 4.2. We already said since the diameter is 12, the radius is 6, so we'll plug that in for R, and we're looking for the theta. Okay, so to get the theta by itself, just divide both sides by the 6 in front of it. So that leaves us with theta equals 0.7. Okay, and I want to fit my units. I'm actually going to reverse the order of this so I can fit the units. Theta equals 0.7 radians. Okay, so radians can be written as a number, and we saw when we first were converting from degrees to radians that it could also be written in terms of pi. Okay, so let's do another one together, and then you may want to hit pause and try the rest on your own, see how you did, try them out on your own, and then hit play and see how you did. Okay, so number 11, the accompanying diagram shows the path of a cart traveling on a circular track of radius 2.40 meters. The cart starts at point A and stops at point B, moving in a counterclockwise direction. What is the length of minor arc AB? So minor arc would be the smaller arc, right? This would be the major arc AB. We're looking for the minor arc AB, over which the cart traveled to the nearest tenth of a meter. So we're looking for the arc length. So we're looking for the S. So if we do S equals R theta, okay, well, we're looking for the S. We know the radius is 2.4, or if you want to write 2.40 like they did, you can. And here's the deal. The angle this time is in degrees. So to convert from degrees to radians, do you remember we multiply by pi over 180? So if you take 165 and multiply it by pi over 180, in the non-simplified form of this, you could write that as 165 pi over 180. If you want to simplify 165 over 180, you can, but you don't have to. Honestly, we're going to just plug this in our calculator anyway and round to the nearest tenth, so you might as well don't waste your time simplifying it. Leave it like this. So if we want to find S in the calculator, you can plug in 2.4 times 165, and you're going to use the pi button, so times pi divided by 180. So try it out, and when you do, make sure you wind up getting to the nearest tenth. You get 6.9 meters. Okay, so now you may want to try out 12 through 15 and then hit play and see how you did. Okay, now number 12, if you prefer to draw out a picture, you can. If you don't prefer to draw out a picture, you don't have to. You can read the problem and you could say, all right, look, they tell me here, the central angle measures 2 pi over 3. So that's telling us what theta is equal to, right? The central angle. Then it says it intercepts an arc with a length of 4 pi feet. So they're saying the arc length is 4 pi feet. So doesn't S represent our arc length? And they're saying to find the radius. So that means find R. That's what we don't know. Okay, so if we use our formula, S equals R times theta, they tell us the S is 4 pi, so I'm going to replace that with 4 pi. The R is what we don't know, so I'll leave that as an R. And they tell us that the theta is 2 pi over 3. Okay, so now if you want to get the R by itself, we got to get rid of this fraction. If you want to get rid of a fraction, you could just multiply both sides by the reciprocal of this fraction, which means you just take it and you flip it upside down. So I'm going to multiply both sides of the equation by 3 over 2 pi. Okay, because what happens is, let's start with the right-hand side. The 2 pi on top cancels with the 2 pi on bottom. The 3 in this numerator cancels with the 3 in that denominator, and it leaves me with just R. And then on the left-hand side, I'm going to make this 4 pi into a fraction. Okay, since this is a fraction, let's make this into a fraction. And there's a couple different ways you could solve this. You could simplify and then multiply across. I'm going to just multiply across. So 3 times 4 pi is 12 pi. And then 2 pi times 1 is 2 pi. And if we simplify this, the pi's just cancel out, and 12 divided by 2 is 6. So the radius, I'm just going to write it over here, is equal to 6, and the units here are feet, so 6 feet. Okay, so number 13. The minute hand of a clock is 6 inches long. How far does the tip of the minute hand move in 20 minutes? Okay, so let's see. I'm going to draw out a clock here. My circles are not always the best, but there's my clock. And how far does the tip of the minute hand move in 20 minutes? So I'm just going to say, let's just say that the minute hand was up here at the 12, Okay, after 20 minutes, it would be down here at the 4, right? That's 20 minutes. Okay. Now, it says that the minute hand of the clock is 6 inches long. So it's telling us that the radius equals 6 inches. And they want to know how far does the tip of the hand move. So we're looking for how far does it move to go from here to here. So we're looking for the S. Now, what we need to figure out here is what angle did it move? Well, let's think about it. A circle is 360 degrees. Now, didn't it go 1/3 of the way through the circle? Because think about it, 20 minutes plus another 20 minutes plus another 20 minutes would be 60 minutes. So if this went 1/3 of the way around the circle, and we know a circle is 360 degrees, you can either figure out what 1/3 of 360 is, which would be 120. Oop, forgot the 0. So that would be 120 degrees. Or you could just say, take 360 and divide it into 1, 2, 3 sections. This is one of them. So if you take 360 and divide it by 3, that'll also give you 120, however you prefer to look at it. But either way, the angle measure in degrees that says 120. That's really hard to read, but that says 120 degrees. So now let's use our formula. S equals R theta. Okay, we're looking for the S. We know the radius is 6. And the angle measure is equal to 120 degrees. But to convert that to radians, we multiply by pi over 180. Okay, and if you prefer to simplify this, 120 over 180 is 2/3. If you want to rewrite this as 2 pi over 3, you can. But, this one doesn't say what to round to on my paper. You know what? I wanted you guys to actually round. I should have written this on here. I wanted you guys to round to the nearest 10th. So I'm going to write that here. Round to the nearest 10th. Okay. So all you're going to do is really just plug this into your calculator. And to the nearest 10th, we get the arc length to be 12.6 inches. Now, let me just show you real quick. If it didn't say to round to the nearest 10th, okay, so this is a side note. This is not what the question says. You would have to do 6 times 120 over pi. If it didn't say to round to the nearest 10th, you'd have to leave your answer in terms of pi. So, I mean, there's a couple ways you can do this, but 120 over 180 simplifies to 2/3. So technically, you could just rewrite this as 2 pi over 3. And then, I mean, however you want to go about it from here, you could just multiply across. 6 times 2 pi is 12 pi. And then over 3. And since 12 over 3 is 4, this would simplify to 4 pi. So if they didn't say, I'm just going to circle that. If they didn't say to round to the nearest 10th, instead of getting 12.6, we would write it in terms of pi, and 4 pi would be the answer. Okay, so number 14, what is the length of the arc on the unit circle subtended by an angle of 120 degrees? Okay, now, here, let's see. Let's draw a circle, and it wants to know what is the length of the arc on this unit circle subtended by an angle of 120 degrees. So let me just cut out a little sector that looks like it's going to be 120 degrees. So kind of like the last question, we know 120 degrees is 1/3 of this circle, right? So let's say this is 120 degrees. And we want to know wrong tool. We want to know what is the arc length. So we're looking for the S right here. So let's see, we're looking for the S. We know the angle, but the R, how do we find the R? Well, this is the clue right here, the unit circle. A unit circle goes out 1 unit in each direction. So basically, from the center, it's going to go out 1 unit in each direction. So what that's telling us is that the radius equals 1. Okay, so let's do S equals R theta. We're looking for the S. We know the radius is 1. And then here, our angle is 120. And to change that from degrees into radians. Remember, you always want to plug in radians into this formula. We'll multiply by pi over 180. Now, I know in the last question I told you to go back and round that answer to the nearest tenth. For this one, I don't want to have you round. We're going to leave it in terms of radians, okay? Now, I don't want you to plug if you plugged in your calculator 120 pi divided by 180, it would give you a decimal that keeps going and going and going. And this question right here, it doesn't say to round to anything. So if it doesn't say to round, we're just going to take this and write it in simplest form. So, I mean, this 1 you can kind of ignore because 1 times anything is just itself. So what we're going to do is we're going to take the 120 pi over 180 and simplify that. So 120 over 180 simplifies to 2/3. So here we can write this as 2 pi over 3. And I guess our units would be units. Okay, they don't tell us the units. We're working with the unit circle here. It's going out 1 unit in each direction. So these would be our units. Okay, and then number 15. So cities H and K are located on the same line of longitude, and the difference in the latitudes of these cities is 9 degrees. So here we go, as shown in the accompanying diagram. The Earth's radius is 3,954 miles. How many miles north of city K is city H along arc HK? Okay, so we're just looking for the length of this arc. We want to know how many miles north is H of K. And since we're going, I guess, around the Earth, that's why it's rounded here. Okay, so we're looking. We know the R, we know the theta, and we're looking for the S. So S equals R theta. So S equals, the radius is 3,954. And for theta, it's 9 degrees, but to change that to radians, we multiply by pi over 180. Now this answer we're not going to leave in terms of pi because it says in the nearest tenth of a mile. So all you're going to do is plug that into the calculator. And when you do it to the nearest tenth, you end up getting 621.1 miles.